Okay, hello everyone. Bit of troubleshooting, sorry for that. Hi, my name is Christos. Thank you very much for attending my talk. Very happy to be here today. So, I won't be clicking away, so I'm going to be standing in front of my laptop for most of the talk. The topic of my presentation today is doing data science the Agile way. And I want to start with explaining a little bit about what it is exactly that I'll be discussing today. Here's what I want to get across is, by the way, can you see everything fine? Can you see the screen? So I want to talk about how does a data scientist fit in an Agile team, and what is his role exactly. And I've got this slide there not only to set the scene for what is to follow in this presentation, but also for clarification purposes, because just reading the title, someone might as well assume that this is a talk about how a team of data scientists work together in the Agile way of doing things. But no, this is really a story about how I have been working over the past 3 years, and I think that I found out a couple of things, some learnings that I felt like sharing with the community, and this is what this talk is about. So, in order to tell you that story, I need to talk a little bit about myself. I've got a computer science polytechnic degree, software engineering, computer science. Completed my doctoral studies in 2015, King's College, was on artificial intelligence. For my thesis, I used many graph analytics algorithms. I became somewhat of an expert in graph analytics, and I decided at the end of my PhD to apply these techniques in the industry. I joined a company called Data Reply UK, a company now. And for the past 3 years, I've been doing data science. I've been involved in short-term roles, temporary projects, doing data science or data engineering. And it was very exciting because I also got to interact with industries like finance, retail, government, even. For the last 1.5 years, I've been placed within this digital transformations group with one of our clients, and I must say things got a bit fuzzy. Didn't really know exactly what I was doing. So here's what was different. Like the usual scenario was, you've got a company, right? They have a problem, they call for the consultant, consultant goes in, resolves the problem, consultant goes out, on to the next challenge, right? And life was great. But with this client, things were different. I found myself becoming part of an Agile software development team, and I went through something like an existential crisis, and I found out exactly who I was. Now, let me pause there for a minute. We'll get back to the story in a bit. This is the overview of what I will be covering today, right? So I want to start with discussing a little bit about what data science is. We need to have an agreement on what is the definition before we can move on to the next bit. I'll then move on to discussing Agile software development, principles, values, practices, etc. Then I'll give you what my view is about what is a data scientist's role inside an Agile software development team. I'll talk about the value of experiments, how you should be creating experiments and not tasks. This is what should go in your backlogs. Finally, some dealing with back pressure, explaining and setting clear expectations to stakeholders, and why that's important and why it's also difficult. And finally, how should work be split. And I'll end the talk with some final remarks. Feel free to interrupt me during the talk if you want to ask me any questions, but I will allow time for questions in the end as well. Okay? So, what is a data scientist? Got these quotes before I start with every section. Accept no one's definition of your life, define yourself. I tried doing it, failed. It was very difficult. So I typed Wikipedia and found some very interesting information about data science. In fact, it's not something that's been around for the past 7 or 10 years. It's been around since as early as 1960. We have Peter Miller, a Turing Award winner. He was actually saying that it's a substitute for computer science. He did introduce some very peculiar terms as well, like datalogy, and then eventually used data science to describe data processing practices that were used around that time. Then we have the International Federation of Classification Societies. They met in 1996 for one of the conferences at CODE, and the title of the conference was Data Science Classification and Related Methods. Later on, 1997, we have Jeff Wu. He is the Director of Statistics and Engineering at Coca-Cola, and he's practically saying that statistics is data science. Data science is statistics. 2007, Jim Gray, another Turing Award winner, and he's saying that data-driven science is the fourth paradigm of science. There you have it, data and science in the same sentence once more. But it wasn't until 2012 when the Harvard Business Review wrote an article called Data Scientist, the Sexiest Job in the 21st Century, that data science really gained a lot of momentum. Everybody wanted to become a data scientist, let alone the fact that people didn't really know what it was. Before you know it, you had international conferences appearing on data science, bachelor degrees in data science, even master's degrees in data science, right? And you have proponents of this whole idea, people like, I'm going to try to say the name, pronounce it correctly, Hope Shlomo, argument will forgive me if I didn't say it properly, who was the director of the master's degree on data science at the Illinois Institute of Technology, who was saying, we have a very clear idea about what data science is, the skills that these people should have. They have to be very good, they have to have strong statistical knowledge, good software engineering skills, and good communication skills in order to be able to convey the insights they extract from data to their colleagues, or to whoever needs to make sense of the data. But at the same time, you have people like Jill Press, who's a writer in Forbes, who was basically arguing that, guys, relax, data science is just another buzzword. It's there to replace business analytics now. People are going crazy about it, but in 5 years' time, something else is going to come in and replace it. People are going to forget it. So yes, you get the occasional beef about what is and what is not data science. I wanted to give you my own definition. I'm actually paraphrasing from what is defined as data science on Wikipedia. I quite agree with this term. It's a professional that uses scientific methods, processes, algorithms, and systems to extract insights from data. And I quite like this term because it doesn't have anything relevant to artificial intelligence in it or machine learning. I don't think that a data scientist is somebody that knows machine learning. I don't think that it is somebody that knows just machine learning and nothing else, or it's somebody that just knows data mining or just statistics. I think it's a more general thing, a more generic thing, and I think that this is a very good way of referring to what a data scientist is. Basically, the way I think about it is like this. I don't know if you've ever seen this pyramid before. You start from data. You don't really understand anything about a pile of lots of data. And a data scientist's role is to help you get from data to somewhere between knowledge and information. I'm not going as far as to say knowledge or even wisdom, if you can ever achieve wisdom by processing data, because I think that if you want to get anywhere between knowledge and wisdom, you need a combination of a data scientist and a domain expert. But in general, that's what I believe a data scientist is, somebody that gets you from data to somewhere between knowledge and information. So, given that we have agreement about what data science is, the next thing is, what is Agile software development? So can I please ask you to raise your hand if you're familiar with the Agile Manifesto, or if you're a software engineer? Okay, so got the slides in. I was thinking that maybe most of the audience would be familiar with it. I'll go through it in detail. Sorry if I bore some of the people in the audience. So what is Agile software development? Agile is a time-boxed, iterative approach to software delivery. It's a way to start building software incrementally through short cycles, rather than try and build it in one go and deliver it, at the end of the project. The whole thing is based on what we call stories. These stories are related to functional components that you identify. Some tasks or subtasks are defined with respect to those components. They're grouped together, they're prioritized, and there's then focus in delivering every one of these stories. This happens within short cycles, and this is a process of continuous delivery. All these are much, much better explained in the Agile Manifesto document that was pieced together in 2001 by 17 engineers that gathered together in Utah. And it also describes a number of values as well as principles that software development teams should abide by. Basically, as far as the values are concerned, what you're looking at on the screen is like 8 values, but we prefer, or at least Agile prefers the left ones to the right ones. We prefer individuals and interactions over processes and tools, because it's nice to have a process in place. Tools are also important, but it's much better to have competent individuals, right? And people that are able to communicate efficiently. Working software over comprehensive documentation, having good documentation about how you will develop things, a nice architecture that is very well defined, or even documentation about how things work is always useful, but it's much, much more useful to have a working software. Customer collaboration, this is one of the key things about Agile. Contracts are also important, of course, but interacting with the end user is much, much more useful. And finally, responding to change. This whole thing is about agility, it's about flexibility. And in an ever-changing environment where we come against constantly evolving functional and technical landscape, in a landscape that evolves like that, you need people that are able to cope with these changes. The value behind using Agile is that you get to maintain focus on rapid delivery and business value. It's about adapting to change requirements, and it's also about minimizing the risk of the overall failure. You do this with this nice code: fail fast and fail often. By going into this incremental development of the software, you engage with the end user much, much faster, because you deliver something, you get feedback from the end user, and you get to identify problems before they manifest into something that will be very problematic and very difficult to deal with. So, we covered what data science is, covered what Agile software development is. Next thing is, what is a data scientist's role in an Agile team? So back to the story. As I said, I'm a graph analytics expert. That's what people call me to help with. 1.5 years back, I found myself with working for a company. Wasn't yet part of the software team. I was there to just do some analytics, try and make sense of the data. I was bundling through data, cleaning data, creating my graphs, applying my algorithms on them, sampling from graphs, using my Python notebooks, using my dashboards. I was extracting insights, discussing them with domain experts, week in, week out. I was doing some work that I'm very familiar with. I was adding value because I was able to identify things that people were not aware were there. So life was great, I was having a wonderful time. Line managers were very positive about my input, until one day, a boss comes and says, well, Christos, you know what, all these things are great. How about we create a solution that automates what you're doing? I like that you are able to produce some insights in whatever way you do it. How about you you piece some things together, and we create a pipeline that does it for us in an automated way. And I was like, yeah, okay, why not? And gathered together with the team, solutions architect, discussed a little bit about what it is that we should do. We put some tasks into Jira after we defined our stories and everything, and got to work and failed. I was really confused at the time, not only with respect to not being able to understand exactly what my role is in the team. I found myself from being a data scientist to trying to build something, so something like split an engineer but a data scientist at the same time, and nothing was really working. Sprints, I can tell you now, they were very ill-defined. We were very far from early deliveries. Scope kept on piling on whatever we were trying to do. It was a never-ending story. I wasn't feeling like I was successful. I was feeling like I was failing all the time. It was very, very stressful. And on top of everything else, as I said, I went into this existential crisis. I didn't know who I was. I didn't know how I am supposed to help my team be better. So I started reading about Agile, trying to better understand how a team works and everything. And at some point I realized what I've got on the screen right now. And this is what I really think a data scientist should do, okay? If practicing Agile software development produces value from learning to failing fast and safe, then a data scientist's role in an Agile team is to help the team fail faster, okay? So, as soon as I realized that, I was like, yeah, I know what I'm supposed to be doing. And I tried applying it. Basically, here's what if I'm to break that down, here's how I think about the whole thing. And before I explain it, I want to take you back to the time I began my PhD. How many of you know how you can go about starting a PhD? How many of you actually have a PhD in the room? Okay, so you must be very familiar with the process, right? So you start with a research proposal. You write down your research proposal, you do a little bit of research yourself, and you select a number of academics, like lecturers or professors that can help you with this process. You send the research proposal, you engage in a discussion with a professor or lecturer, and then somebody is going to say, yes, I'm happy to work with you on this topic, let's start working together. So I did that. 2010, I started working with a supervisor at King's College, and I walk in his room first day, and I'm like, okay, I know what the problem is, let's start working on solving it. And he said, well, Christos, wait a minute. You have to do a little bit of literature review. You need to read a couple of things and be able to place your problem nicely within the literature, because at the moment, you have a very broad idea about what you're trying to solve. And I did that for a year and a half. And it was the most difficult thing I ever had to do. I, at that point, realized that the problem with doing a PhD is not about solving a problem, but finding a problem to solve. And now I'm doing that every day. This is what I do every day as a data scientist, right? I come in, I'm part of a team, we discuss about what we're trying to develop. I try to identify all the assumptions that are in place, things that the team assumes that we know are there or need to be there for something to be successful. And I see it as my responsibility to be one step ahead of everybody else in saying, but do you know for sure that this works? And the minute I identify that assumption, the next thing to do is try and prove it or disprove it. This is what I refer to as iterative hypothesis testing. This is what I think data scientists should do. And it's all about experiments. Not tasks, experiments. That's what should go in your backlog. So let's discuss experiments. Don't cry because it's over, smile because it happened. People do not like experiments. Going back to why we were not being so successful in the project I was involved in, there were too many assumptions in place. And I didn't realize that at the time. I thought that, okay, I understand the data, I've applied my algorithms on it, I've seen it work, I was able to extract some insights about it, but I didn't really account for all the problems that would arise when you try to productionalize, I don't know if there's such a word, but when you try to bring something like that into production. So I was constantly coming across things that I wasn't able to understand because I had an incomplete understanding of the data. And basically, here's how I would put it. We moved from a successful data analysis to product development too fast. There were many hypotheses that had to be validated in order to bring this platform to life. It was a lot of experiments. We were not experimenting enough. Within the Agile context, when you have to try something and you're unsure, people refer to it as a spike. I'm going even further than that. I'm not talking about spikes, I'm talking about experiments. And the thing is, it's not just about trying things, it's about thinking hard about what it is exactly you're trying to prove. And I must say here that just the thought process counts. Just going into the process of really thinking hard about what it is you're trying to confirm is going to be useful. It's going to be useful to you, it's going to be useful for the team, and it's going to be useful before you even try to disprove it. It creates a better understanding. By hypothesis is never going to help you a lot, but anyway, the process of going into defining what your experiment is going to be is what will eventually be useful. The goal, as I said, is to learn by failing. Failing, however, is not something that people welcome a lot. As I said, research here is key. But dealing with failure is the most difficult thing you'll have to do when you try to introduce experiments into Agile software development. I don't know if you're familiar with this quote. Insanity is doing the same thing over and over again, expecting different results. At some point, you need to stop thinking about what's going wrong and try and fix it. But you'll get a lot of resistance from people when you try and experiment with things, because when you experiment and you fail, when you fail to prove that an assumption was correct, people see it as a drawback. See a comment on the screen, it reads, "Tim, believe me, it's not a problem that you did not get your story done until the end of the sprint." Pause there, and then that shouldn't happen too often. The thing is, the term experiment carries negative connotations. Most product managers are trained to avoid them, mitigate them. They don't want you experimenting. And it's not just that. When in fact we should be approaching experimentation as something that tolerates failure for the sake of learning, we are always up against back pressure by people who think that this is not useful, this does not add to business value, I don't have anything to show to anybody, what have you been doing, is the question that you'll definitely come against. It's about culture. It's about culture. And cultivating the right culture is going to be difficult. It's difficult because it's difficult to find the courage to be uncertain. Find the courage to introduce work that leads to something that failed and say, okay, this is not going to be useful in terms of reusing it or applying it somewhere else, but it's definitely going to be useful in terms of what you've learned. It's also about how stakeholders see this work. If they don't understand the value of experimentation, it's going to be very difficult for you to introduce this kind of work into your everyday activities. Loss aversion will eventually kick in, and when it does, it will expand and encapsulate every single person in a team, from software developers to even stakeholders themselves. This is, however, 100% natural human behavior. There's nothing to do about it. It's just that you have to stop trying. You have to introduce the idea behind failing faster and the value of learning and prove it by just doing it. Splitting work. Yes, this is not my best joke. Someone needs to have smart code there, as I need me. Splitting work. You need to start by thinking what it is that I'm trying to prove. The minute you do that, the minute you identify all of your objectives that will lead to that more broad goal, you'll be able to prioritize your objectives accordingly. The next thing is to think about each objective, the questions that need to be answered, okay? And once you do this, you need to start thinking about the experiments you'll run in order to confirm every one of those questions. This is how you define a set of subtasks, for example, associated with every one of your goals. Eventually, these subtasks are going to be grouped together to create a story. And there you have it. You'll have your data story, and that's exactly what goes into the backlog. I wasn't sure about whether I'd have enough time to give you an example here. I had one in mind, which is a perfect fit for this scenario. I didn't put it into my slides because I wasn't sure about whether I'd be able to share my slides afterwards. So I'll try and give you one idea about what it is I'm trying to do at the moment, for example. I cannot explain anything relevant to the domain, but I'll try and keep it simple and at least theoretical. So suppose, for example, that we have a stream of events. Unique IDs coming in, and you're doing stateful processing. How many of you are familiar with stateful processing? It's a process, okay, thank you. It's a process by which you apply some sort of logic that relies on a previous state, and you try to infer the next state or identify the next state, and you maintain the state in memory, okay? Suppose that we're talking about a customer's journey on a website before they buy something, right? Somebody enters the website, the minute they come in, they're in the initial state, and then when they access, put something in their basket, they move from that state to another state. This is clickstream analysis. And obviously the IDs here are the distinct customers of the website, right? So suppose that for some reason, you start monitoring these transitions from one state to another. And you want to start raising alerts when you identify something, something that you care to identify, okay? This could be either based on a number of features that characterize that user. It could be based on how a user behaves on the website. How do they change from one state to another? Changing between states could be potentially modeled as a sequence of transitions. This sequence of transitions could be a string, okay? That string is something that you could use to make your prediction. Using that over using features that you extract about a user could be more useful. If you want to raise alerts based on the behavior or based on features that you identify are relevant to a user, you should work in different ways. My job in this case, for example, would be to try and check, okay, what are the transitions that people go through in a usual journey? Okay, what is normal and what's not normal? How long do these strings get? Can I come up with some sort of an algorithm that will be able to compare this and identify what's normal and what's not normal? Should I be doing this prediction in a way based on features that characterize the entities or the customers in the website rather than rely on how they transition from one state to another? And if I decide, for example, that this transitions sequence is what I should rely on, if I want to do this at real time, when exactly do I start saying that, okay, this seems to be very close to something that I've observed before? After like 5 transitions, after 10 transitions, what is the maximum size of a transition that we've seen? What is a distribution of different sizes? All these things are assumptions. Somebody comes in and says, well, I want to do a little bit of prediction about how people behave on the web page. That's fine, yes, definitely you can do it. But how do you do it? And the things that you need to tackle before you can say, yes, we'll do it and we'll do it this way, is a very assumption-heavy work. Final remarks. I'm not going to say everything is running smoothly at the moment. The project I'm working on is fine now. I think I've got a much better idea about how I can add value to my team. I split my work between doing a little bit of engineering and a little bit of data science, day in, day out. Things are working, I'm quite happy. There's a lot of back pressure about bringing in experiments, and it's not always easy, but I'm trying. In general, when it comes to Agile software development, I think it's a great practice. It's not a panacea. I really believe, however, that it's very valuable in the sense that it helps you identify problems very, very early. When it comes to data scientists and Agile, whether they go hand in hand, well, I think that that is the case when you have an Agile software development team that struggles with data. When whatever needs to be built relies on assumptions that are relevant to data, then I think that a data scientist is a good addition to the team. Of course, that is the case that's based on the assumption that there are many hypotheses to be tested. And yeah, what I want to leave you with is that we need, as a community, to embrace and cultivate this experiment-friendly culture. I want to end the talk with one of the things that Douglas Squirrel said in one of his podcasts. How many of you are aware of or follow the Agile troubleshooting podcast? So very, very interesting podcast. I definitely recommend it for you. There was an episode, I think it's number 21. It's called Failing and Learning Fast. And in that episode, Douglas gives an example of a case where this is best understood. It's based on a story, a fictional story, and it's about Beethoven, I think. So allegedly Beethoven has this star student, he's a violinist, right? And goes to Beethoven and he's like, Maestro, I've tried all the pieces, I'd like to try something new. And Beethoven is like, okay, I've written this new piece, here you go, try it, and come back to me and tell me how was the experience. So the student is excited, takes the new piece, goes home, and begins to practice it. And he reads the first instruction, and the first instruction says, you have to play the first note while standing on your head. And he moves on to try and cover the next instruction, which is to try and play a high note and a low note at the same time. So your hand cannot extend that far, so you just kind of play it. And the instructions get wilder and wilder as you go deeper into the piece. So eventually, at some point, the student gives up and goes back to Beethoven, and he's like, Maestro, I've tried my best, but it is impossible to play the piece. To which Beethoven responds saying, yeah, I forgot to let you know of an important detail. Of course it is impossible to play. I wrote it to be impossible to play. I was looking for the sound that is generated when somebody tries to play it like that. What he was trying to say is that even if you fail to apply these practices, the failure is still something that produces desirable outputs. And this is why we should always strive to practice, to apply best practices. They're always useful, and even if we do not realize it, we can always leverage value from them. You try to do TDD, for example, and if you don't do it perfectly, you'll still derive value from just doing it. Same goes for BDD, same goes for doing Agile. Maybe you don't do it the best possible way, still you'll extract value from it. That's all. Thank you very much. And more questions.